Welcome back to the Core Hub. My name is Dr. Fakat Kazmi and today we will discuss about support vector machines. Let's look at its common applications. Applications of support vector machine. SVM is widely used in various fields such as face detection, text and hypertext categorization, image classification, and bioinformatics. These are just a few examples. As we go through this lesson, think about other possible applications. Today, we will cover the following key sections. Number 1. What is machine learning? Why is support vector machine? What is a support vector machine? Understanding the support vector machine. Advantages of the support vector machine. A real-world use case. What is machine learning? Machine learning can be divided into three main categories: supervised learning, unsupervised learning, and reinforcement learning. SVM falls under supervised learning, where we train the model with labeled data and make further predictions. Why the support vector machines? SVM is primarily used for classification problems. For instance, imagine trying to classify fruits as strawberries or apples. We provide the model with labeled data for strawberries and apples, and once trained, the model can identify a new fruit as either a strawberry or an apple. What is the support vector machine? SVM is a supervised learning method that sorts data into two categories. By finding the optimal boundary or hyperplane, SVM maximizes the margin between different classes. This margin helps in making accurate predictions. Understanding the SVM with an example. Consider a simple example of classifying men and women based on height and weight. We plot this data and draw lines to separate the two classes. The optimal hyperplane is the one that maximum the margin between the two classes. This ensures that new data points are classified correctly. Advanced SVM concepts. In more complex scenarios where the data is not linearly sparsable, we use kernel functions. Kernels transform data into high dimensions, making it easier to find a sparsing hyperplane. This allows SVM to handle intricate classification tasks effectively. Advantages of SVM. Number 1. High dimensional space. SVM works efficiently in high dimensional spaces. Number 2. Effective with sparse data. It performs well with sparse document vectors. Number 3. Regularization parameters. SVM avoids overfitting and bias issues, making it a robust algorithm for various applications. Real-world case. Imagine using SVM at a zoo to differentiate between crocodile and alligators. By training the model with labeled data based on features like size and sonnet width, SVM can accurately classify new observations. This is just one example of how SVM can be applied in practical scenarios.